Okay guys, we got a little review for Q18. I'm going to start with the top. So first thing we want to do is draw in our velocity vectors. If we take a look and see how this comes together, we've got our X arrows remaining constant, and then it gets down to the bottom, and then our Y arrows, they steadily grow in size until they get to be about, I'll make this one a little bit bigger, until they get a little bit bigger until they're this size when they hit the bottom, and then we can answer questions about it. Like for example, the Y velocity increases, the X velocity remains constant. You can see that all the arrows are the same in the X while the arrows in the Y get bigger. The overall velocity when it lands, the dotted line, is bigger than the initial arrow, so it increases, and the overall acceleration remains constant. The reason the down arrows grow is because gravity, and there's no acceleration in the X, meaning they're staying the same. Then we're ready to solve for how long the object's in the air for. So if we want to solve for that, we want to use this equation, square root 2d divided by g. So we'll say 2 times, make sure you grab the y, 65 divided by 9.8, and we square root everything. So we plug that in our calculator. We get 2 times 65 divided by 9.8, and we square root that, and we get a total time of 3.64 seconds. So that's our first blank here, 3.64. Then we're ready to find the X velocity. Remember, in the X, Vx is equal to the range or the distance in the X divided by the time it took to fall. So we already know the time it took to fall, we just found that. And then we want to solve for the X velocity by taking this, the dx 50, and dividing by it. So we take 50 and we divide by our previous answer, and we end up with 13.7 for our velocity. Once we have that, we can fill in that blank, and we're ready to solve for the Y velocity. So to find the Y velocity, we're going to take gravity times the t. So we'll be taking 9.8 times the time it took to fall, which was 3.64. So we take our same time again, and we multiply by 9.8, and we get 35.7 for our Y velocity, which is considerably faster, and that's represented by the picture. 35.7, and that's considerably larger than 13.7. So now we have each side of our triangle. So at this point, we're ready to go ahead and solve for what we're after. So we have 13.7 going this way, and then we use head to tail addition. We put in 35.7 this way, and then we're ready to solve for this, the resultant. Now remember, normally this line would be over here, but we picked it up by its tail and put it over here. Remember, X and Y are always 90 degrees from each other, and that's why we can use this trig to solve for it. I would recommend using your Psi tools and plugging it in that way. In Psi tools, you go in here, you go to 4 vector calculator, clear out what you got. You can put in an X of 13.7, and then we can put in our Y, 35.7, and then we can hit view. If you want it to reflect exactly what you see on the paper, you can always make the 35.7 be negative, and then it will move down, although it will give you the right answer either way you do it. And so we get a resultant of 38. I just did Pythagorean theorem and inverse transform, and it gave me 38.2 for my overall. My R value, my overall, would be 38.2, and my angle is negative 69 degrees below the horizontal. And so that's how you do the first one, which I don't think is really too bad. The next one we'll look at here in the next video.